Right, good afternoon everyone, or good morning I guess to our North American, American viewers today. So just having a quick scan through the attendees box, and it looks like there's a couple of familiar names, but looks like a lot of people that I haven't dealt with before. So just to introduce myself, so my name's Ellis McCoy. I'm the Regional Sales Manager for the south of the UK and the Nordic region, both for security and also our hazardous area equipment. We did a presentation this morning to our primarily kind of like our European customers, and it went well. So hopefully we can do the same for you this morning, afternoon, depending on where you are. So today we'll be looking through a guide to lighting for transport applications, and this is primarily from a lighting standpoint, and also just from the experience point of Raytec as a whole. So to give you a bit of background, Raytec, I guess very proud to say that we have probably decades of years of experience in transport applications, and dating all the way back to some of the earliest applications of its type. So Project Glutton, for example, one of the first projects that was specifically focused on capturing number plates, and then moving on to speed check a little bit later, and then bigger projects such as the London Congestion charge, but also more recently smart motorway projects both in the UK and various places. Turkey, for example, is a very recent one for us, and also the same in the US as well. So where did we come from? So as I say, Project Glutton, this was a project that was rolled out in primarily Northern Ireland. And it came from a reaction to the increased terrorist threat from the IRA. So very simply, the British government wanted to be able to have more control over the borders, see who was entering the country, hopefully identify any individuals that were known to the authorities as posing a threat to the country. And so that was that. It was very much a defensive reaction, where the first, or one of the first ANPR applications came from. At the time, it was a very technologically advanced application, and used Zoptic technology. And Zoptic technology actually was first or used in the Superman movie, and the gent who used it in the Superman movie went from Hollywood to ANPR in the north of Ireland, bizarrely. But yeah, so that was used there, and as I say, it was very ahead of its times in terms of the actual application and what we were able to achieve with it. Later on down the line, we started to become a little bit more advanced. So we've been involved with applications such as Project Speed Check in the UK. So this is an application whereby primarily around kind of critically safe stretches of road. So where there's roadworks, there's going to be people on the side of the road that are vulnerable. And the aim here is to track the average speed of a vehicle passing through these zones. So the number plate will be taken at the start of this zone, and then multiple times throughout, and then finally at the end they'll calculate their average speed of the entire area. And obviously those who have exceeded this dramatically will get a letter in the post. This is something in the UK that's been extremely effective, and I think the vast majority of people take careful attention of their speed when they're in these zones, as opposed to the old, security camera on the side of the road where perhaps somebody wants to slow down, but only for a brief period of time. We've also been involved in projects where we have perhaps had a more ecological environmental standpoint. So the London Congestion charge was introduced to obviously reduce the amount of cars and vehicles within the city centre, both to reduce the amount of pollution in the city centre, but also to stop the traffic that was building up over time. Initially, this was introduced in 2003, and there was about 700 cameras initially. This was extended in 2007, and I believe it was extended to about well over 1,000 cameras. So it was, at the time, it was one of the largest ANPR applications in the world. Obviously, it had an environmental motivation behind it, but also the scheme itself brought about 250 million in annual revenue. So there was definitely a sense of return on investment in terms of a highly accurate NPR system being introduced. So what we'll go through today, and just to explain this all straight off the bat, so OCR being optical camera recognition, sorry. This is just one way of saying ANPR, LPR, and various other ways that people will describe the same thing, i.e. cameras recognizing and processing number plates from their images. You'll notice I've already called it ANPR multiple times. You might not call it that, but we're all talking about the same thing. We'll touch a little bit on the argument of integrated solutions versus separate. We'll also talk about some other ANPR OCR applications that we've been involved in. Some kind of future developments or kind of recent developments in terms of recognizing vehicles, but also passengers inside. And finally, we'll be looking at some just a few little case studies from the Raytec side of things. And then we'll finish with a Q&A. So just just to kind of touch on that point as well. So you'll all have a little question button on your control panel. If at any point you kind of want me to ask a question, feel free to type it in that box. I'll try and have a look as I go along. Perhaps it'll wait until the end, but feel free to ask me anything that you want to know. If I can't answer it immediately, I'll pass that on to my technical colleagues who will be able to look at it in a bit more detail. So, what are the challenges? What are we faced with when we're designing an ANPR system? The first thing is speed. So even if it's a relatively low speed application, say entry into a car park where vehicles might be going 15 miles an hour, for example, this is still a lot faster than your average security camera. And the level of detail that you're able to capture when a vehicle's moving, that speed is vastly reduced. Increase that to 70 miles an hour or 100 kilometers an hour on a motorway, and obviously, as you will all well know, trying to capture any sort of detail with a regular CCTV camera is nigh on impossible. The next thing that we come against is headlights. So obviously, directional light is very important, and we want light to be reflecting off an object back into the camera. If the light source is directly in front of a camera, much in the same way as if somebody shone a light in your eyes, you would squint, you wouldn't be able to see anything. Unfortunately for ANPR applications, that's exactly what happens throughout the night, every night. So there's certain tricks and techniques that we need to employ in order to prevent that glare from damaging the accuracy of your images. The next thing is lighting conditions. Obviously, it goes without saying that throughout the day, a camera might have ample light in order to see what it needs to see, but at nighttime and dusk especially, that's where it starts to reduce. And it's at these times that I think Raytec definitely step up and become a lot more important in the overall solution, being able to provide accurate level of detail at all times throughout the day and the night. Weather. So for myself, looking after the Nordics, I've been asked to work on many projects where things like ice on the number plate is one of their kind of factors that they need to think about. We also get involved in applications in the Middle East, in Americas, etc., where the varying weather conditions can pose a very individual kind of reaction to the cameras. And the third one there is most commonly seen in the UK, where on any given day throughout the winter and the summer, we can have all three of the rain, the clouds, and the sunshine. And then finally, plates. So plates themselves provide a very interesting confrontation point with cameras, depending on where you are. And this is another reason why it becomes very localized. So to give you an idea or a flavour of the different plates that we've been tasked in order to helping to see, as you can see, it changes dramatically from your Middle Eastern plates, where the lettering is very, very different, to a standard blocky black lettering, different colours, different materials, etc. Same again in America. Every state has its own individual number plate, and it, well, as some of you will well know, this can be a very, very difficult thing in order to counter. So just before we kind of go into how we can work to avoid this and how we can look at different ways of cancelling those challenges, how does the light work in these kind of scenarios? So the most commonly seen type of reflection, and this is a little bit sciencey, but the type of reflection most commonly seen in the natural world is diffuse. So this is where the light will bounce off an object and bounce in every direction. In this kind of circumstance, the camera might only actually receive about 5% of the light that's been shone on a certain object. Thankfully, though, number plates don't often actually carry this property, and this accounts for about 5% of plates that we have to look at a daily basis. The second, the least common is specular, so the third one on the list. So this is actually only really for man-made objects, say glass mirrors, very, very shiny metals, or possibly extremely still water, where the light will reflect off the object and bounce in a completely different direction at the same angle. In this kind of instance, essentially no light is getting to your camera, so all of that light is going elsewhere, and your camera wouldn't be able to create, or it wouldn't produce a good usable image. Slightly less common than, or slightly more common than specular is retroreflective. So retroreflective materials are purely man-made. They don't occur anywhere else. This is where the light will reflect directly off the surface and directly back at the light source. And this is the perfect scenario for number plates, but also just anything that you see on roadways. So for example, the traffic cones, signage, the reflective vests that my wife makes me ride to work in, etc. They're all retroreflective, so the light directly bounces off. And that accounts for about 95% of number plates that are produced. So as I say, most are retroreflective, approximately about 95% of plates are retroreflective. However, as you can see, it's very geographical. So to give you kind of examples, in the UK, the number plates are particularly consistent. We've been manufacturing the same. It's either on a retroreflective white or yellow background with black lettering, which makes it quite easy for the cameras can see. Within Europe, it's the same again. So European number plates generally follow the same rule of thumb. However, you do have a couple of outliers, such as Belgium, which have their own couple of manufacturing kind of individualities, I guess you'd say. And then you go to places like the US, where every state has a very different plate, and that's where things become very difficult in case people are traveling cross borders, etc. And then Canada, for our Canadian colleagues who may be on the chat, obviously you've got the same again there. So what changes? What changes between the different plates? The first thing is material. As I said, with UK number plates as an example, We use the same material across them all, no matter where you're from in the region. It's a retroreflective backdrop with the black matte colouring on the top. This is almost the best case scenario that you can have, and we'll touch on the highly advanced in just a second. However, materials can change massively depending on where you are. So you could have plastic number plates, you can have metal number plates that are matte, and these all come with their own different reflective characteristics. Size and quantity. So I believe in some states of America, you only have an individual number plate. Some places they might have very small number plates. It could be just that the lettering is quite thin or very different to different regions, and or there just might not be very much of it. So all of these factor in where the camera should be looking, what it should be looking for, and this should be individually catered for depending on which region you're in. Colour is a very big one for us. So colour, say in the UK again as an example, and the black is easy enough for infrared to pick up. It reflects well. In some places where perhaps they have the red lettering, obviously, as you can imagine, with infrared being on the red spectrum, it doesn't create that level of contrast, so your camera pretty much doesn't pick it up at all. In places where red lettering is used, often we've seen in the past people using white light for their ANPR applications, or potentially other wavelengths of light. So blue, for example, we've been requested numerous times in the past, especially in South America. And finally, font. So worst case scenario, when you have in some Middle Eastern territories where the lettering is extremely thin, very small, so very difficult for the camera to differentiate between different sections of a number plate or different individual characters. The Netherlands here, or the Dutch, they've been actually very advanced with their ANPR applications and their number plate technology, I guess you could say. So in their particular instance, they have the retroreflective background, the matte black lettering, very thick, very easy for the camera to see. But then they also include little details or little cues for the camera to look at, so that it can distinguish properly between lettering that it might usually be confused by. So if in this example, if you see on the right hand side, the R there, there's a little notch taken out of that R. And in the Netherlands, the cameras will be taught or told to specifically look out for these little notches, these little obscurities that actually help it and assist it in order to identify properly exactly what it's looking at. So what do we need what's our solution? So first of all, we need a good camera. We of course need a very good lens. In some cases, a cut filter, whether that be a visible light cut filter or not. Of course, good lighting, and then all of these in combination lead to, if you look after each individual part, they can lead to a good solution. Unfortunately, to refer to the old adage, if you're putting garbage in, then you're going to get garbage out. So if you're using poor componentry across your solution, or even a weaker part, then unfortunately that's going to lead to a reduction in your overall accuracy. So when we're looking at a project, we've got the fast-moving objects, we've got challenging lighting conditions, and we've often got high-quality requirements. That all those three factors are coming into play, and we need to be able to work around them and set our solution up, set our high-quality solution up in order to achieve good results. So to start off with, how do we combat the fast-moving objects? Well, first of all, we need to alter the shutter speed. So a regular CCTV camera that we might often see out in the field, normally it'll be set to about 1/50th. In this example, we've got the contrast between a slightly slower shutter speed of 1/15th and then the shutter speed that we most often see for ANPR applications, which is 1/1000th or 1 millisecond. As you can see between the two images, the level of motion is very apparent in the left-hand side where the shutter speed is slower. When you start to increase that, you're getting greater detail, despite the fact that these water droplets are moving obviously very fast. Just to give you another example, we've got a fan here, so 1/8 of a second at the top left there, which is you can't see any detail whatsoever, and as we go faster and faster, we start to see more detail, and we start to see the individual fan blades as they're spinning around, going all the way to 1/1000th, which nicely is again what we would suggest for ANPR applications, where you can see the full level of detail of those individual blades. But what does this mean for vehicles? So if you're using that 1/50th of a second that we would normally say for it's kind of a standard CCTV application, the vehicle's moving 70 miles an hour, between two frames, or between the camera opening and shutting to take that image, the vehicle will have moved 62 centimeters or 24 inches. That's what's causing the motion blur. That's why it's difficult for a security camera or just a regular camera to get a detailed image of a fast-moving vehicle. If we increase that shutter speed to 1/1000th, then we're starting to see a big reduction in the actual travel of that vehicle, so to 3 centimeters and 1 inch. And this is within the regions where you're going to get a lot more detailed image. The downside of using the fast shutter speed, even though it's an absolute requirement for these kind of applications, is that less light is going to be hitting your camera sensor. So I guess very simply, if we're opening and shutting the aperture, the lens very quickly, you're essentially letting a lot less light through that. As you can see here, so we go to 1/250th in the top left there, which is quite reasonably fast, faster than a standard security camera, to the 1/60th, which was probably what we would consider to be around, well, between that and the 1/30th for standard security, down to 1/2 of a second, in which case you're letting in so much light that it's actually overexposing the image. So again, 1/50th of a second or 20 milliseconds versus 1/1000th of a second or 1 millisecond, you're actually reducing the light hitting the sensor by about 20 times. So it is a big reduction in the amount of light power, or the flip side, you need a lot more light in order to get the same level of quality image. The next thing that we can do is change the aperture. So this is to fight the headlights, fight the sun, fight reflections. The idea here is that we need to close the aperture as much as possible. By doing so, you're actually also going to increase the depth of field that you're going to see. So if you imagine you're looking at a motorway, it's unlikely that you want to see just a 1 meter stretch of motorway. It's more likely that you want to see as much motorway as possible, so that the camera has as much time as possible in order to recognize those plates. It also, again, works in conjunction with focusing. So you adjust the depth of field, adjust your f-stop or aperture in order to focus on the stretch of road that you're specifically focused on. Again, as with the increasing of the shutter speed, reducing your aperture or increasing your f-stop essentially leads to a lot less light. So to give you an example of this again, we've got the lower f-stop at the top left, higher f-stop bottom right, and as you can see, as you slowly adjust that, you're starting to reduce the light, and well, it's very clear to see that you're going to see a lot less light. As it happens, the FStop 5.6 is around about where we would suggest setting your camera to for an ANPR application. As I mentioned, the aperture is also closely linked to the depth of field. So in photography, for example, you might want to have a very low f-stop in order to create a nice depth of field for a specific location or object that you've taken a photograph of. However, we often want to be able to see as much as possible, so we want to reduce that aperture, increase that f-stop, so that we're seeing a big stretch of road, for example. So as I say, 5.6 is what we would typically suggest for your NPR applications. This is opposed to about 1.4 f-stop for a CCTV application, and this reduces the amount of light hitting your sensor again by 16 times. So this works together as well. So it's a cumulative factor when you're taking into account the 1/1000th shutter speed and then the increased or reduced aperture, increased f-stop. So yeah, as I say, you times those, and somebody that's very quick at math can probably work that out. I'd probably need a calculator, but I'm sure it's about 300 and something less light getting to your camera sensor. At the end of the day, the lighting is critical, and especially as the case if you're looking at unmanned locations. So this is an example at Heathrow Airport. This is completely unmanned at all. Of course, this is quite low speed, so the vehicles aren't going to be driving in especially fast, but it's imperative that they have extremely high accuracy, and in which case, even though it's very low range, very low speed, they're still using quite a large amount of light in these areas in order to get that pinpoint accuracy. So what's the magic formula? Again, as we say, you want all of your four parts, and they all need to be correctly specified for the job. But in terms of the actual settings for your camera, we would suggest a shutter speed of 1/1000th or 1 millisecond. You can go faster, depending on the environment that it's in. I've seen this can be multiplied by a few times. I have also seen slightly slower as well, so it is very dependent on the area that you're looking at. Aperture set to 5.6. Again, this is more. This isn't just from a kind of reduction in the glare aspect. It's also for your focus and your depth of field. You want to keep your gain to a minimum, so you want to keep the images as crisp as possible. Gamma set to 1. A narrow band pass filter. So this is mainly for applications if you're going to be using infrared through the day as well as nighttime. But if you are using the daylight, then that's perhaps not as necessary. And then, of course, you need quality with a good quantity and the correct wavelength of Raytec lights to go alongside that. So, and as I say, you need the correct light. So taking into account that 20 times less light and that 16 times less light getting to your camera sensor, we need to be able to ensure that the correct size product is specified for your requirements. This is something you can do yourselves. There is a method to it using the inverse square law. As an alternative, you're obviously more than welcome to get in touch with us, and we can assist with the maths for you, albeit perhaps not myself, as I've already shown the quick math is not on my side. So one of the questions that we're often asked is the argument of pulse versus constant light source. So the constant light source is obviously something that Raytec is very well known for, and we've provided it for security cameras for 11 years, plus the years that our directors have previously worked on it. It's considered to be easier to set up and easier to maintain. People understand it. If you look at a white light that is constantly on, you don't need to try and synchronize the shutter speed of your camera. It's always going to be there. Pulse brings with it other opportunities, but perhaps at the cost of an additional setup. So why would you choose Pulse? The first one, very simply, is when we're pulsing an LED product, we can massively increase the amount of light output, more than 5 times the amount of light output. So in essence, what you can do is you can either use a larger lamp and just get as much light as you possibly can, or as an alternative, you can potentially use a smaller product with lower consumption and still be able to provide the same light output as a much larger constant source illuminator. As a byproduct, because the lamp's pulse light, for example, may only be on for 1 millisecond through a 20 millisecond cycle, and you're looking at a much lower operating temperature. And while that's not necessarily benefiting your ANPR solution as a whole or your accuracy of your images, what it will do is increase the lifespan of the product. LEDs actually like being pulsed. It's good for them, and because they won't build up heat, which is a detriment to their lifespan, they'll last you longer and produce a higher power output over a longer period of time. Finally, for infrared mainly, this pulsing a product also will reduce the visual impact. So despite you actually pulsing in a much higher power output, the visual perception to the human eye is actually a lot lower. So when you're looking at that lamp, you won't perceive it as being as bright or impactful as a steady state product. The caveat to that could be white light being used. And this again can be quite region dependent. So to give you an example, we were working with a company in Finland where they tested out the pulse white light products, and they deemed it too jarring to passers-by. And this was in a location where there was going to be pedestrians, or not necessarily pedestrians, but people working on site on foot, and they said it wouldn't work appropriately. Conversely, if you have ever been to Dubai and you drive into one of the many hotels, you'll notice they've all got pulsing white light products facing directly, with very little distance between the driver and the pulse product, and to them it's of no issue. So again, it is quite a region-specific thing. In some places, it's not seen to be the best method of using it. In others, actually, they see it as not being a problem. And one of the ways to get around this as well is the use of infill pulse, which can even out a pulse product, and that's something that we're working on being able to offer on our regular, our new pulse products. Overall, though, I think it's easy and safe to say that the pulse products give you a lot more functionality over a standard steady state product. Again, it's whether that increased functionality is worthwhile for your application, and whether the cost benefit also kind of works with you. But as on a whole, I think the pulse products work very well subject to your camera. The other kind of aspects as well in terms of the increased functionality is that you can have different power levels. So perhaps you could have different pulses at different levels at different power outputs. Perhaps you can have different wavelengths. So we also provide the hybrid products where it's a mix of white light and infrared, or it could just be different wavelengths of infrared, as we'll see later on in the presentation how that can utilized and can be effective. So this is somewhat a bit of a joke from our chairman, Tony Whiting. The use of hi-fi is perhaps a little before my time, but apparently the aficionados at the time would battle it out over the effectiveness of an all-in-one versus a separate solution. So I guess you could say the geeks out there would probably suggest that a separate solution would provide you with better quality of stereo versus an all-in-one built-in unit. And this is very much the same for your ANPR applications as well. So why would you use an all-in-one, for example? First of all, it's very much easier to specify because, of course, you don't need to think about all the individual parts. You just buy a single product. Easier integration, again, because you don't have all the individual pieces. You don't need to think about how they all fit together. All of that work, hopefully, is already done for you. Easier sourcing because you're getting everything from the same place. You're able, much easier to procure all of the, the one part that you're looking for. However, the all-in-one solution does have a few downsides. So the first being that it somewhat limited performance capability, or rather the flexibility is somewhat limited in that it will only achieve what it's been designed to achieve and not necessarily what you wanted to achieve in your specific project or application. It also means, in terms of the flexibility as well, you're very much tied to that particular software provider. It's going to be very difficult for you to change up one specific part of your product, whether that be, the latest software has just been launched. You're going to be quite stuck with that. But then you're also stuck with the cost side of things, or the recurring charges, etc. So why would you build a separate unit? Obviously, in complete converse to the all-in-one solution, you have the unlimited flexibility. So perhaps you want a solution, say if you're looking at a stretch of motorway, but some areas you want to be looking at lay-bys, some areas you want to be looking at the way down a long stretch of motorway, somewhere on a corner where you don't need very much power. You'd have the opportunity to specify exactly the right camera, exactly the right amount of light, the lens, etc. for each individual location. It also gives you the opportunity to specify exactly what you want there as well. So obviously with an all-in-one, you're somewhat limited in your knowledge about what they're actually using, whereas if you've sourced all the individual parts, you can ensure yourself that it's all as you hope and as you want it to be. Referring back to our garbage in, garbage out, if you don't know what you're getting, then it's a little bit more risky. We would probably suggest the separate solution for the more demanding applications. So for environments where they're particularly threatening to the cameras, or perhaps just on stretches of motorway where you are going to need much further distances or much higher accuracy, that's where separates, I think, really come into play. Again, so in terms of your tender reports, if you're responding to a tender, it allows you to put in the specific parts that will meet that, and then it gives you the commercial freedom to essentially buy what you want, where from, etc. And you can obviously vie for your best pricing. Third-party software, as I mentioned, we work with a lot of different software manufacturers, and it does give you a lot of opportunity to tailor your system to actually what you need, whether that be a car park scenario where you're just looking at slow-moving vehicles, or if you're looking on a motorway at fast-moving vehicles. And finally, potentially reduce maintenance costs. Depending on the quality of your all-in-one solution, it's somewhat more difficult in order to maintain that or replace parts over time in case of breakdown. So just to summarize, obviously we've seen the challenges, we've seen the solutions, and there is a bit of a systems approach. I think overall, though, we can see that lighting is key to everything, and as long as you've got the correct products in place, you shouldn't have any issues with the speed, the weather, the lighting, etc. We had a look at the pulse versus constant, which again, it's very much dependent on which works for your specific location or your specific project. For example, pulse products might be better suited for the higher power applications or the longer range applications, whereas a constant, as I've worked on plenty, are very, very well suited to, well, anything even up to the longer range, but car parks, road networks, that kind of thing. Again, the all-in-one versus separate. So the benefits of both are quite clear, but I think for the more critical applications, sometimes the separate approach wins out. So just to run through a few of, I guess, in a sense, our case studies. You've seen kind of the background of where we came from in terms of traffic applications. A lot of it has been road orientated, but not everything. So this in particular one is the National Railway in France. In this case, the trains are obviously moving, well, they are moving a lot faster than, say, 70 miles an hour as they would be on the road. And the other difficulty with this, of course, is that infrared, the red glow that is produced from the standard wavelength of 850 nanometers, is potentially seen as a warning signal to trains. So to counter this, they have to use covert lighting, which for the CCTV guys among you will know doesn't produce the best of images. The reason for that is the covert infrared is not necessarily any less powerful than standard infrared, but cameras simply aren't susceptible to that wavelength of light. So what you'll find is that with exactly the same size product with the exact same consumption, this is the infrared product, I mean, you'll get a lot darker images using 940, which is the full covert, as opposed to 850, which is semi-covert. So the result of this project, or the way to get around that, was essentially to just use as much light as they possibly can. So in this instance, they've used 8 panels in order to capture the serial number on the front of passing trains and record them as they're going along. Obviously, it was successful, as you can see in the image on the right there. They get a very clear shot despite the headlight and despite the fast-moving nature of the trains. This was quite an interesting one. So this was UK ports, but I believe it was also Spanish ports as well. So this wasn't necessarily just to monitor it's shipping containers. It wasn't necessarily just to monitor the container serial numbers, although that was actually one of the big aspects of it. It was also from a litigation standpoint that they needed to prove that all the containers were passing through without any damage while in transit. So they would have the camera pick up the serial number. It would then look at any damage caused to the containers as they pass through the port. Vehicle APR LPR recognition, and this one is in the UK specifically. So if you drive down the M6, the M1, M5, etc., you'll no doubt be very accustomed to the smart motorway projects that we've got going on here. And the interesting one about this is that as you can see on the pole there, the yellow pole, you've got your APR camera, you've got the infrared there, so great, that's capturing the number plates. What they also have here is a series of white light illuminators off axis to the road, which is in front of the sign on the left-hand side of the image there. So these products are set to a very, very narrow field of view, and the aim here is to, in a snapshot image, they can capture the make and model and color of the vehicle, as well as obviously the number plate from the ANPR camera. What I wouldn't suggest, and this is something I always end up doing, is if you're driving down one of these roads, don't look up to the right to see the lovely Raytec lights, because it's very, very blinding, but it's also very effective at what it does. And if you are just traveling in a straight line, because it is off axis, you wouldn't ordinarily be jolted by it. Something that we've become or we've been asked about numerous times, especially actually in the States, is high occupancy vehicles or high occupancy pool roads. And in which case what the aim here is to see if there's multiple passengers inside the same vehicle so that they can be charged the appropriate toll. This brings with it its own set of challenges, I guess you could say, namely that window screens can be very different in terms of their tint, very different in terms of their thickness, the material that's used, whether it's got radiator material going through them, etc. So this does make it very difficult in order to see that. By using an increased level of infrared light, though, we are able to get full facial recognition from inside of a vehicle. One of the tests that we did just the other month before our Intersect show is this is my colleague Steve Carell kindly testing for us. And as you can see here on the left-hand side image, we're getting fantastic detail through the windscreen. However, once he pops his head out, you'll realize how much extra light we need in order to get that level of detail. And obviously, when he's putting his head out, he's not covered by the windscreen, it's overexposing. And that also leads to difficulties when you're needing to see inside of a vehicle, but also to see the number plates at the same time. But it is something that we're working on and something that we've been able to achieve and currently achieving, well, as a very recent example, on the main roads through Dubai itself. The other thing that we're working on at the moment is utilizing different wavelengths of light, which I touched on earlier. So this is especially the case when we're wanting to look through windscreens, but we found that lower wavelength infrared is actually a lot more effective at producing a usable image when you're wanting to see detail from within a vehicle. So it's very slight in these two images, but if you look at the 850 and compare it to the 730 nanometers, you'll notice it's a little bit darker there. And the 730 nanometers we've decided is definitely something to test should you have a requirement for seeing inside of a vehicle. Something my Danish colleagues this morning were quite happy with is the project that we worked on earlier and well, last year, I think, which is hard shoulder monitoring in Denmark. So this particular one, it's not necessarily to see vehicles or capture their number plates, but it's to see obstructions on the hard shoulder so that they potentially open it up at key or very busy times. And again, that's something that we've seen mimics in the UK as well. So much similar to the smart motorway projects. These applications here, they monitor how busy the flow of traffic is, and they can promptly change different settings or different speed variations in a given zone. So if it's very, very busy, they might reduce it from 70 miles an hour to 40 or 50 miles an hour. Or alternatively, at some places where it's safe to do so, they'll open the hard shoulder to allow for extra traffic flow in that given area. Somewhat frustrating sometimes when you're driving down the main road towards London Way, because you might get to the point where perhaps in 10 miles there's traffic and they're slowing you down at 50. It's always difficult to fight the urge to just drive at normal speed when you've been told to go a bit slower. Similar to the French railway project, this is one in the US though, where again they're trying to look at the serial number and the registration of the trains as they pass. Again, trains are an interesting one because just often it's the case that they're going a lot faster than a moving vehicle. In this particular case, I don't know what the exact speed is, but I don't think it was quite as fast as the French trains, primarily because they've got a different purpose. I think this is cargo rather than people freight, I guess you could say. And finally, this is something that our UK customers especially will perhaps recognise, and this is essentially environment monitoring along a lot of the major roads. These can be found anywhere from just normal motorways down near London, but also this particular one is up in Scotland, up in the mountains. So this in particular, using Mobosix cameras there, it's specifically designed to be able to take a lot of, I guess, a lot of horrible temperatures, a lot of snow and a lot of ice, and in doing so, they can measure the wind speed, they can look at the road conditions, if they're wet, if they're icy, if they're snowy, etc. And this is all fed back, I believe, via wireless protocol. So just to kind of summarize and look at what you need to look at when you're actually thinking of specifying the lighting in particular. First of all, is the wavelength. As we've touched on, there's lots of different wavelengths that you can choose from. And again, this is very much a region-dependent factor. So in the UK, infrared is perfectly fine if all you want to see is the number plates. However, in some parts of America and some parts of the Middle East, where red lettering is used, perhaps you're going to have to start using white light or the blue light that we've seen used in the past. The next thing is the field of view. So probably goes without saying, but you want to be able to match the field of view of your lamp, so the angle of the light, to that of your camera. So you don't want any hot spots, you don't want any dark patches around the outside of the image. The power and the quality of the light needs to be effective in order to give you desired results. Again, this is just coming with the specification. You can work this out yourself. However, we are also more than happy to help you out in terms of the exact equations and calculations. Obviously, much in the same sense as the field of view, we have different angles. So if you're looking at a very wide multi-lane application, you're going to need a lot wider angle than, say, if you're using looking at just an entry road or a gateway entry into a car park, for example. We would, of course, suggest field proven, and hopefully I've given you enough evidence that you think that Raytec products are field proven, because we've had many years experience in this. And finally, we would always suggest testing the products, and this is something that we're more than happy to assist with. So if ever is the case that you've got an application, you want to be able to show your customer perhaps the effective operational status, or how it's going to work, of the camera, then we can provide demo loan units or perhaps assist with project specific demo pricing. Perhaps you also want to look at the additional features. So on a very simple basis, our regular Vario products have the capability of being controlled by the remote control, where you can change power settings, photocell sensitivity, timer function, etc. This is just, it's more from a setup point of view to assist and make it a little bit easier. You don't need to climb up a cherry picker or a set of ladders in order to take control of the product. The next step up from that is IP capability. So we have IP products that can sit on your network, and they can be used in conjunction with like a direct integration with a certain software, whether that be VMS or other. We also have the capability of controlling our products by HTTP control. So essentially anything that can send out a string command can control our lights, and you can create quite I want to say intelligent, kind of sophisticated setups with just a handful of string commands. Finally, as I mentioned briefly, the hybrid lighting. So we've got products that can produce two different wavelengths of light at one point or another. Normally for security, we use the infrared and the white light. However, we also can do it with different colors of light, different types of infrared, etc. One thing to think about as well is that the products that you're using are correctly certified for the environment that you're putting into. I guess one of the benefits of the Raytec products is the sustainability, and we've got products in the mountains in Finland and in Iceland, but also we've got it in the deserts of the Middle East. So they're very, very suitable for a vast array of different environments that you're putting these products into, and definitely no concerns if you're putting out in the desert somewhere under the sun all day. So just to kind of go through it very quickly once again before we finish up. Obviously, you have the choice between the pulse and the constant products. As I say, constant being a little bit easier to install, easier to design, pulse giving you that additional functionality, perhaps a better cost advantage, but with a slightly more complex installation. And then you've also got from ourselves as a brand service, you've got full access to our lighting design service. As I say, or as I've said a few times, we're more than happy to help you out with any calculations that you need to make. Again, it's always more important when we're talking about ANPR applications. Demo units, we're more than happy to get any demo units shipped out if you've got a project that requires it. And we can also do custom build product design. So, for example, the lower wavelength of infrareds, that came about specifically from projects that required it. Same for the blue light for ANPR as well. Here's an example of the lighting design. So this is more from a security standpoint, but we can, mainly we do it for your white light scenarios. However, we can give you a depiction of what you can expect from infrared, which can be useful, especially when you want to just make sure that you're matching the field of view of the lamp to the particular scenario, say if it is the multi-lane motorways. And that's me. Hopefully you found this interesting. I'll have a quick check and see if we've got any questions. If not, or if you need or if you want to ask a question later on, I should say, then by all means you can pop an email to our marketing team. They'll forward you on to your local reps. For the American viewers on today, we do of course have the North American office, which will be glad to receive any inquiries that you've got. Again, if you don't already have contact details, I'd imagine a lot of you do, then you're more than welcome to get in contact with them. For any of the European, Middle Eastern, or just the rest of the world, then by all means, again, email marketing and we'll put you in the right, or you'll be put in the right place. John Donaldson asks if the copy of the presentation is going to be available. Yes, I believe everybody should receive the presentation after we've finished up here. Might take a day or two. The good thing is that there's full notes on here as well. Almost to the point that you wouldn't need me to talk to you. The good selection of notes. So yeah, as I say, that'll be sent out to you all, and hopefully you can pass this on to other colleagues or what have you that need to learn a bit more about it. One of the things I was asked earlier on today was if Raytec were planning on building or releasing an all-in-one unit ourselves. The answer to that was quite possibly in the future. This is something that we're looking at. As some of you might be aware, we already have the VLK, or the Very Lighthouse kit, which essentially is a camera housing with lamps mounted onto the sides. And there is discussion at, although nothing set in place at the moment, that there might be an all-in-one solution with cameras with an integrated software that we could release in the future. It would likely be in conjunction with our partners, but if that is something that would be of interest to yourselves, then by all means let us know. John Murphy has asked if there will be any follow-up or advanced classes concerning aiming and positioning. Interesting one, actually, because what I suggest to my customers for setting up of their products is we do provide I forget the name of it now, but essentially it's a little periscope that you can fit onto the fins of the heatsink, and you can look and see where it's aiming at. So you perhaps put a cone where you want the lights to look at, and then you'd look at a daytime setup tool. That's the one. Actually, what I would suggest as an alternative to that is if you can get a laser pointer or something similar. whack that on the top of the lamp, and then you can aim it exactly where you want to. So even if you're using infrared, I guess this would be mainly for, but if with the infrared, if you've got a laser pointer on the top, then you can very easily aim it towards your target location. With regards to positioning, rule of thumb, or we suggest customers mount obviously with your camera. With security applications, we say about 1 meter apart, but with cameras that have sufficient like weatherproof cover, etc., you're not really going to get any glare from the lamp itself, so you can mount it in line with your camera. It's probably the best case scenario. We have obviously, as we pointed out for the UK application, where they have off-axis angle. That's very specialist, and probably we would suggest doing a little bit of testing to make sure that works out for what you want it to do. Stephen Gillette asks, does Raytec make relay modules to activate or deactivate lights remotely, or do you work with another product? So the various products themselves, they come with telemetry input, which is just a normally normally closed switch. So that can be used in conjunction with another product in order to switch the lights. We do, of course, have the IP products that you can use in conjunction with the software or cameras, or well, anything that can control another product or send controls via string commands over a network. They can remotely trigger and communicate with our lights. So you do have a couple of options, either hardwire connection or via an integration of some such. Looks like that might be it for now. As I say, just thanks again to everybody that's joined us on the webinar today. Much appreciated. Hopefully you all found it of interest. It's a topic that can be quite technical, but at the same time, you know, with a bit of thought, it's not too bad. Yeah, no, thanks everyone, and let us know if you have any questions. We're more than happy to help.